Chapter 4.1 Day 1 Graphing Polynomials Functions. Polynomial functions. Recall that a monomial is a number, a variable, or product of a number and one or more variables with whole numbers, exponents. For example, if you have any positive or negative number, that is the type of monomial. Any single variable with any degree or exponent. Multiplication of two numbers, that number can be fraction or positive or negative or square root. And if you have 2x squared y cubed, this type of number is also monomial. Just remember, if there is no plus or minus sign in between these terms, that will be called monomial. If you introduce plus or minus sign in between these monomial, that becomes a polynomial. So a polynomial is a monomial or a sum of monomials. A polynomial function is a function of the form. This is the type of form. You start with the highest degree and then degree goes down by 1. So for example, you have a 5 and then this one would be 4 and 3 and 2 and 1 and constant. The exponents are whole numbers and the coefficient is the number that in front of the variable. In this case, the coefficients for this polynomial is an minus 1, a1, a0, all of those. They are always real numbers. For this function an, which is in the front, and you can see that x to the power n is the highest exponent, the number that is in front of the highest exponent variable, that number is called leading coefficient. So an, that's this one, is called leading coefficient because it's in the front. N is called degree. So the highest exponent that we're talking about, that's n, is called degree. And a0, you can see that there is no variable. So that's called constant term. A polynomial function is in standard form when its terms are written in descending order. So if you start from the highest degree and go down by 1 or 2, that is called descending order. So for example, if you have any polynomial and you start with the highest degree x to the 5, then x to the 4, then 2 times x to the 3rd, and so on so forth, you are going to call this type of polynomial is standard form, starting from the highest and go down and write it in a descending order. So now we are going to discuss common polynomial functions. This table really helps you understand the degree and the type of polynomial and what is its function. So if the degree of the polynomial is 0, then it's called constant. Means there is no variable. It's just a number a0, a0. So we can call that polynomial, for example, just a number without a variable. If the degree is 1, then we call this type of polynomial, we call it linear. And you have seen linear polynomials in the past. Just for example, if you write 2x minus 3 or 2x plus 3 or anything that is in the form of mx plus b, it's called linear, and that's the type. The type of the polynomial when the degree is 2 is called quadratic. You also have seen this type of polynomial. We just call it like, let's see, if it is 2x squared plus 3x minus 7, this type of polynomial is called quadratic. For the polynomial that is the type is cube, it means the degree of the polynomial is 3. Degree means the number that is the highest exponent in the polynomial. So we call degree 3 because this is the highest exponent in this polynomial. The type of polynomial you would see in this case could be 4x cubed minus 5x squared plus 2x plus 3, something like that. And the last one we have is a degree 4 polynomial, and it's called quartic. The type is quartic, and the highest exponent on this one is going to be 4. So that's why it's a degree 4. The type or example for this type of a polynomial could be 2x to the 4 plus x cube plus or minus 1. Let's see. So you can see that there in this one you have x squared and x term missing. Even though the x and x term are missing, still it's going to be called quartic because the highest degree of this polynomial is 4. Now let's do example number 1. Here we are going to identify polynomial functions. You're going to decide whether each function is a polynomial function. If so, if you decide that this is a polynomial, then we are going to write it in a standard form. Remember, standard form starting from the highest degree to go to the lowest degree, descending order, and states its degree, its type, and the leading coefficient. So when you're looking at letter A, fx, which is a function, equals negative 2x cubed plus 5x plus 8. So the polynomial, if it is a polynomial, so we can investigate here. All the exponents are whole numbers, and the numbers that are in front are real numbers. So that is going to be a polynomial. So yes. Is it in a standard form? Yes, because it's going to start from the highest degree and then x squared, which is not there, that's okay. And then x term and then constant. So the standard form is already there. We can rewrite it. So it is in standard form, but we can write it here because we have a space. Degree is the highest exponent. So the highest exponent is 3. So we're going to write degree as 3. Leading coefficient is the number that in front of highest exponent, and that number that is in front of the highest exponent or degree is negative 2. So the leading coefficient is going to be negative 2. Letter B, we can see that all the coefficients are real numbers. So yes, that's going to be your polynomial. Also, the degree or the exponents are all whole numbers. So we can see that this is going to be your polynomial. Standard form is going to be starting from the highest degree or highest exponent. So we should have square root x to the power 4 in the front, and then x to the third, and then constant. Now it is in standard form. The highest degree is 4 because that's the degree is 4 because that's the highest exponent in the polynomial. Leading coefficient, that is square root 2. For letter C, polynomial hx equals negative x squared plus 7x to the power negative 1 plus 4x. Is this going to be a polynomial? Let's investigate. So we say that all the coefficients, that is number that in front of x, should be real numbers. So they are all real numbers, negative 1, 7, and 4. And we say that the exponent should be all whole numbers. So we see here, this is a whole number. This is a whole number 1, but this one is a negative integer. So that makes it no. So this is going to be no, because this is not a polynomial. And then if it's not a polynomial, then we do not answer the rest of the question because it doesn't apply here. For letter D, the coefficients for this one is 1. But if you look at this one, 3 to the power x is an exponential function. This is not a polynomial function. Polynomial function is x to the power something, not x to the power whole number, not whole number to the power x. So that makes it no. So we're going to say no and do not answer the rest of the questions. You try problems for example number 1. Decide whether each function is a polynomial function. If so, write it in a standard form and state its degree, type, and leading coefficients. Question number 1, fx equals 7 minus 1.6x squared minus 5x. And we can see that all the leading coefficients, all the coefficients are real numbers, and the degree or the exponents are whole numbers. So yes, this is a polynomial. Write it in a standard form, highest degree term in the front, and then x term, and then last is the constant. For question number 2, you have the polynomial x plus 2x to the power negative 2 plus 9.5. Is this a polynomial? So let's investigate here. The coefficients are 1, 2, and 9.5. So the coefficients are real number, which is fine. But if you look at the exponent, this is exponent 1, negative 2. Because it's a negative 2, so it means that this is not a polynomial. Because exponent is negative 2, is negative 2, so it's not a polynomial. For question number 3, the coefficients are 1, negative 6, and 3, so they are real numbers, and the exponent is 3, 1, and 4, so they are whole numbers. If the exponents are whole numbers and coefficients are real numbers, then yes, this is a polynomial. And it's not in a standard form, so we're going to write this in a standard form by writing the highest exponent in the front, and then after that the lowest, and then the lowest. The type of this polynomial is quartic, and degree for this one is 4, and where the leading coefficient is going to be 3. Now we are going to do example number 2, evaluating polynomial functions. So we are going to evaluate the function for the x value. In example number 2, the x value is given as x equals 3. So we're going to use plug it in or substitute the x value, that is 3, into the equation or function, and then solve using PEMDAS. So we're going to use PEMDAS, which is parentheses, exponent, and then multiplication and division, and then addition and subtraction. So that's going to be 2 times 81 minus 8 times 9 plus 15 minus 7. So that's going to be 162 minus 72 plus 8, and that's it's 90 plus 8, which is 98. Now we are going to do the U-try problem number 4, where we're going to use x as 4 and use the PEMDAS to solve or evaluate this function. 4 to the power 3 is 64, and there is a negative in front, so negative 64. 3 times 16 plus 9, that's negative 64 plus 48 plus 9. So that's going to be negative 16 plus 9, and the answer is negative 7. So next, number 5, we are going to plug it in x value equals negative 2 into the function. So x is negative 2 here, plug it in for the x values, and use the PEMDAS, means you're going to solve the exponent first. So 3 times negative 32 minus negative 2 to the power 4 is going to be positive 16. Remember, when the power is negative, power is odd, then the negative remains negative. If the power is even, then the negative will turn into positive. This is going to be negative 6 times negative 2, that's 12, and plus 10. 3 times negative 32 is negative 96, minus 16 plus 12 plus 10. 12 plus 10 is 22, negative 96 minus 16 is 112 negative. When you combine that, you're going to get the answer negative 90.